Good morning, everybody, and welcome to episode 4 of the Prospering from the Energy Revolution Challenge 6 in 60 webinar series. We've got an excellent lineup today of speakers speaking to you about technology and infrastructure innovation from their perspective. And we will have six speakers as well as questions and answers towards the end of the session. So this webinar is brought to you by Prospering from the Energy Revolution Challenge. The challenge is a UKRI funded program as part of the Industrial Strategy Challenge Fund. The program started in 2019 and will run until March 2023 next year. And we've funded over 50 different projects as part of this program. The program objectives are to prove local energy business models that are investable, scalable, that deliver cheaper and cleaner energy, that build prosperous and resilient communities, and that benefit the system as a whole. We have funded over 180 different organizations, and you're going to get to hear from some of those organizations today as part of this webinar. And lastly, on Prospering from the Energy Revolution, so we have over 50 different projects ranging in scale from large-scale demonstrator projects to technology and digital and data projects. I'll let you look at this map at another time, but basically we're funding projects right across the UK. The focus of today is on technology and infrastructure innovation. And do please ask questions and post them into the chat. We will have time at the end of the webinar to get to those questions. So I'll waste no more time talking to you. I'll get straight over to our first speaker, who is Brian Wan from Scottish and Southern Electricity Networks. Brian is going to be speaking to you today about some of the excellent work that SSEN are doing as part of the LEO and transition projects, and which are focusing on SSEN's transition to a distribution system operator. Over to you, Brian.
Great, thank you very much, Damon. So I'm struggling, Macaulay, with the clicker on the slide, so if you don't mind helping out, that would be great. Could you flick to the next slide, please? Great, that one's perfect. So today I'm going to give you an overview of some of the technology that we are developing to push forward the smart local energy systems. And if you flick to the next slide, please. So as part of the project, we have various different industry partners. We leverage funding from 2 different work streams, from the traditional IUK fund stream that Damien's mentioned, but it's also part of the Ofgem's network innovation competition. So for me, it really is about greater than the sum of the parts for this project. And without further ado, we'll jump into next slide, please, Macaulay. So I'm going to really give you an overview of the technology that we're developing. So in the context of today, I'm talking about flexibility services. So that's a deviation from a baseline, so a change in generation, a change in demand for an asset. And as part of that development, we're developing multiple IT and technology systems for those flexibility services. So let's start off and focus on the interface between the industry actor and the DSO, which is our market platform, so the NMF, which is shown in green at the bottom. And that's a new platform that allows trading of flexibility between the DSO and flexibility providers, but really importantly for us, facilitates peer-to-peer trading on the network. And I'll mention more of that later. And then the second system, which is really important to us, is the coordination platform. So the whole system coordinator, and think of that as a data hub. It draws on data from various different sources, including the NMF, which I'd mentioned, and power system analysis. And its main 2 functions are to identify solutions to constraints on the network, but secondly, assess the impact of those important peer-to-peer trades. And in support of that, we're developing other really important tools, including a power system analysis tool, where we've developed a network model for Oxfordshire across different voltage levels with near real-time topology changes. And the important takeaway point for this, from my point of view, is these are not DSO-driven tools. They're developed in collaboration with our partners in LEO within Oxfordshire. So next slide, please, Macaulay. So we talked about flexibility services. We developed the neutral market facilitation platform, which is a new platform for flexibility assets to log in and register their capabilities, register their requirements. And in combination with the coordination platform, which I mentioned, that which draws on the data, we can derive the requirements for flexibility on the network within different time frames. And so why is that important for Grid Edge? Well, that potentially helps the support of the deployment of cost-effective flexibility to maintain network integrity, but also as a potential alternate route to network reinforcement. And these two platforms are being tested now in real-world physical trials in Oxfordshire. So next slide, please, Macaulay. Thank you. So we know we need a service. The NMF is a platform that allows bidders to log in and bid and contract for a range of flexibility across different procurement timescales. So that goes from a season ahead timescale right through to intraday. So that allows stacking of services for flexibility providers. The platform is also the platform which dispatches the service on the day. So as we move closer to the dispatch day shown in red, we go from a season ahead market right through to week ahead intraday. And then we've got different dispatch timescales based on the service, which could be 12 hours in advance all the way through to a dynamic type service, which could be 30 minutes in advance. So that allows us to test different market models and different routes to market. And as we move towards different dispatch timescales, we've got fluctuation in flexibility prices. We've got more certainty on what needs to be procured for the network, and the asset owners have also got more certainty on that capacity and availability of their asset. Next slide, please, Macaulay. Okay, so you've delivered a service. I presume you want paid for it, and we all would do. So we've developed a baselining tool which integrates to the market platform, where flexibility providers can log in, they can upload their actual data for the flexibility period and a view of the historical baselines. That enables a comparison between the requested and delivered amount, and it gives transparency to both parties and accurate payment for that service. So it's really important. The tool's been really successful, and it's been adopted, and it's now being jointly developed by the Open Networks Project Workstream 1A. So a big tick in the box from a project point of view. The next slide, please, Macaulay. So I mentioned certainty previously, and I'm going to skim through these next two slides. How do we know what certainty we've got on the network? So we've developed an operational forecasting model for specific substations in Oxfordshire across different time horizons, and that draws on data from generation customers, demand customers, but takes into account weather and calendar, etc. And that provides a prediction of what's needed. Next slide, please, Macaulay. And you're saying, so what? What does that mean for Grid Edge? Well, the takeaway for me, it provides that certainty as to what would be procured for flexibility, but also what would be dispatched. And then last slide, please, Macaulay. So I mentioned what's really important to us within the LEO program is the work that we're doing on the peer-to-peer trades, where the DSO isn't procuring the service, it's a DSO-enabled service. And we've got some exemplar services that we're developing around import and export capacity, where you've got new access rights through trading of capacity. We've got an offsetting service, which is a nuance which I don't have time to get into, but that really is important to us within the Oxfordshire programme, because that facilitates others access to the network and driving towards net zero. And really, in the time I've got left, I don't have much time to go through peer-to-peer in any great detail, but hopefully it gives you a really whistle-stop tour of the ambition of the LEO project and the complex and novel systems that we're developing to drive towards that smart local energy system. And I'll hand back to yourself, Damien.
Excellent, thank you, Brian. That was fascinating stuff. Next, can I hand over to William Goldsmith, who is from EV.Energy. So William is going to take you to the user-centric view of developing solutions, and in Will's case, EV charging solutions that are user-centric and designed for users, but can also enable those electric vehicles to be assets to be utilised for managing the grid. Over to you, Will.
Yeah, fantastic. Thank you, Damien, and thank you, Brian, as well, for that really interesting presentation on Project LEO. So EV.Energy is a software platform that's making electric vehicle charging simpler, greener, and cheaper for everyone. And in terms of Project Leo, which is creating this flexibility marketplace in Oxfordshire, EV Energy is building the world's largest virtual power plant of electric vehicles, and so is a flexibility provider that participates in demand response programs and flexibility markets. Our mission as a company is to make electric vehicle charging greener, cheaper, and simpler, and to accelerate the decarbonisation of transport. And we do this by working very closely with electric vehicle drivers to solve their real-world problems. Electric vehicles, as many people know, are accelerating rapidly with the growth of electric vehicle sales really rocketing across Europe and also North America. And for most people, driving an electric vehicle is hands down just a better experience than their previous petrol car. However, the biggest challenge that we always come across is the pain point of charging and how do you get that vehicle charged? And the two main questions that come up is how do I charge my vehicle at home and how do I charge my vehicle on that long road trip? Electric vehicle charging also causes a major problem for utilities and typically happens at peak times. Sorry, so I've just skipped slightly too far ahead there. So generally people will come home and plug in their car when they get home from work or their day out. And what this will do will cause this is also aligned with peak times on the energy grid. So this is when electricity has higher carbon, is more expensive in the wholesale market, and also there's more constraints on energy networks and it's more complex to manage. So what EV Energy solution to this is smart charging. So by shifting when people charge their vehicles, so people typically are plugged in for like 14 hours overnight, but only need to do 1 to 3 hours of charging. So what our platform does is automatically, based on users' requirements, pick the best time to charge, which is the greenest. So when there's the most renewable generation on the system, the most wind and solar, when it's cheapest in the wholesale markets. And then we also respond dynamically to different grid events and constraints in order to provide flexibility services and help balance the grid. Our algorithm does this by responding to a combination of price, carbon, and grid capacity signals, and critically avoiding overloading the network during the evening peak, and using smart charging to spread that load out throughout the day. Our platform works by integrating a cloud-based platform that integrates with the electricity markets and energy utilities. We then control and manage charging by connecting directly with smart charge points and also directly with vehicles through their telematics, and provide a friendly user app to drivers through the EV Energy app, or that's sometimes branded with white labels through our utility partners. We've got a couple of really exciting projects, innovation projects that we've been running with Innovate UK. The first is maximizing grid services from electric vehicles, and we're very excited to have had this project extended recently. So we're now going from where we've tested and piloted and signed commercial contracts to now actually scaling up this technology so it can start to deliver services and value in the energy system across the whole of the UK and also now internationally. The other project that we've done with Indra is called Advanced Grid Billing and Asset Metering Services. And this identifies that to deliver some of the more complex national scale services, like providing response in the balancing mechanism, has stricter requirements around metering. And therefore, we've been looking at how residential demand response can participate in those markets as well. So over the last 2 months throughout these projects, we've worked on over 10 world-leading projects, really collaborating strongly with industry. So we've done some fantastic work with UK Power Networks through Project Shift, which was the world's largest smart charging trial. We had over 1,000 electric vehicle drivers participating in that trial over a 12-month period. And I think the final report is due to come out in the next couple of weeks. That is then a fantastic use case of how innovation translated into the business as usual activity and the commercial activities of the DSO, and updated the rules and the structure for their flexibility procurement. We then went on to win the UK's first contract to provide grid services from domestic electric vehicles with UKPN last summer, and in December have now delivered that. So it's the first virtual power plant of electric vehicles to go live in the UK, delivering commercial grid services. We've also been engaging lots with other DSOs, including WPD through Intraflex and SustainH, working with platforms like Piclo and Nodes, Scottish Power and SSEN as well. What we've also started to do is take this internationally, so we're expanding into the US and providing grid services in markets like Texas and California. And there's also a very interesting energy market now developing in Australia. As I'm running out of time, I'm going to quickly skip through some of these slides. Overall, we've been able to demonstrate that domestic electric vehicles can provide a substantial and reliable demand response. So through Project Shift, that's typically reducing peak EV load by 80%. And so, yeah, we're now scaling this up and expanding this across the UK with DSO markets, and also working with our aggregator partner Flexitricity to try and bring these services into the UK balancing mechanism. That's all from me. Please get in touch if you're interested to find out more.
Excellent. Thank you very much, Will. And can I just remind everybody viewing in at home to please do send in your questions. We're going to have a questions and answers session with all of the speakers at the end of this webinar. I think some people might have had slight technical hitches getting on at the start of the session. So please do send in any of your questions as they come into your head. Next up, we've got Lisa Lebedev from Habitat Energy. Lisa's going to be speaking to us today about Habitat's role and experiences of operating one of the world's, or possibly the world's largest hybrid battery system as part of the Energy Superhub Oxford project. Lisa.
Hi, thanks so much for having me. So Lisa Lebedev from Habitat Energy, just going to walk you guys first through a little bit about what Habitat does overall, and then we'll get into what we're doing in the context of Energy Superhub Oxford. So first, Habitat is a grid scale battery optimization and trading company. We're operating in the UK now, and soon we'll be operating in Australia and the US, so similar to EV Energy in terms of countries. And we manage these battery assets, and then we trade the energy in the power markets. And I can get into that a little bit later on. And just to kind of, the way in which we do this is really focused on trying to scale our operations. And so we combine algorithmic decision making with a human in the loop, or a commercial team that facilitates the algorithms decision making. Those algorithms make a decision with a combination of what is happening in the market. So they're deciding across a number of different markets, both everything from day ahead through to the balancing mechanism, as well as ancillary services. So services that we provide to the grid. Our algorithms are making decisions across all of these markets, but they're combining that with an understanding, or kind of an asset knowledge. So it's an understanding of batteries specifically, but then assets individually as well. Just jump to the next slide. So one of the things that is really important within that, you can't just make decisions in absence of the asset that you have on your system. You really need to understand the capability of that asset. And one of the things that is very particular about lithium ion batteries specifically, which are the bulk of battery storage facilities that are on the system and in the pipeline, are lithium ion batteries. They degrade over time, and there's a cost to replacing the cells as they degrade. And so a lot of our decision making can't be done in a vacuum. It can't be done just kind of in a single moment. You need to always be considering what is the impact that my current commercial decision is going to have on the long term, the lifetime value of this asset. And so we really try to gear our algorithms to be always considering what is going to be kind of the marginal degradation cost of the cycle of a battery or of that extra megawatt versus the marginal revenue that we're getting from it. As I was saying before, the other component of this that is really important is also thinking about what the asset specific characteristics are. We've talked a little bit already about how the network is different, the constraints are different across the country. We need to be taking that into consideration when we're making any commercial decisions or we're making any decisions about the asset specifically. Likewise, not all batteries are created equal. And so we need to also consider what warranty constraints we were working within, or what limitations the site has, particularities that the site has that need to be considered whenever we're trading the asset. So that's what Habitat does overall. I'll just get into a little bit about what we're doing in the context of Energy Superhub Oxford. So ESO is one of the Prospering from the Energy Revolution programs funded by Innovate UK. And as Damien said, it's really focused on delivering innovation in smart local energy systems. And ESO is focused specifically on Oxford and how we can really combine this consortium of private and public sector parties to achieve that in the most kind of innovative and efficient way possible. So ESO looks at a number of different sectors. It looks at the heat. It looks at electricity, it looks at electric vehicles, both public and private, to see how all of these pieces can fit together. And within ESO, there is what Damien hinted at, which is the world's largest hybrid vanadium flow lithium ion battery, but it's also the UK's first transmission connected battery. So a number of different firsts that we're working with there. But this site, you see on the slide there a visualization of it. This is located just outside of Oxford, actually, and basically Habitat is operating this site. At the moment, only the lithium ion is live. We're still in the process of commissioning the vanadium flow. It's set to go live very soon. And but for the lithium ion alone, it's operating in both the merchant markets and in ancillary services, as well as providing some of these kind of new transmission connected services that we otherwise haven't been providing. So it's definitely kind of a learning experience for both sides. The final thing that we're doing is we're also facilitating Oxford City Council's public EV fleet and helping them determine how they can optimize their charging schedule to reduce costs, reduce strain on the system, and just provide a more efficient operation. So similar to a little bit to what EV Energy is doing. And I guess the point of all this is just to say, this combination of a number of different partners is really what is enabling us to drive this innovation. Without Pivot Power and Invinity, we wouldn't have a hybrid battery to operate. And without ESO, we wouldn't have this kind of infrastructure that would facilitate our collaboration. And so really, I think that's the takeaway message, that together we innovate faster and better. So I'll stop there and I'll answer any questions at the end.
Excellent. Thank you, Lisa. And just once again, if I can reinforce it, please do ask questions into the chat. We will get to them at the end. So next up, we've got Simon Powell from Marine Southeast. Simon's going to be speaking to you about the Port Energy System Optimization Project, which is an excellent project down in Portsmouth International Port, looking to decarbonise the port infrastructure down in Portsmouth. Simon.
Great, thank you, Damien. It is indeed an excellent project. So I've got 7 minutes to explain about the project and why we're doing it and what we're trying to achieve. So I'm Simon Powell from MSC International in Southampton, and talking about the PESO Port Energy Systems Optimization Project. The project has 4 partners. Ourselves, we're a not-for-profit organisation facilitating innovation in the blue economy area, so the maritime sector. Swan Barton Limited, who are specialists in energy storage, particularly flow batteries, applications and control systems. The Energy Systems Catapult, who are a not-for-profit centre of excellence, who are created to accelerate the transformation of the UK's energy system. And we are conducting this project on the ground in Portsmouth International Port on the south coast of the UK, a major UK port with ferry services, cruise ship visits, and a deep water cargo terminal. So why are we doing the project, particularly in doing it in Portsmouth? So Portsmouth, along with many other cities, has significant air quality problems, and the city is one of the first to introduce a clean air zone last November, but it also suffers from the emissions of ships visiting the port, both whilst they're underway transiting into and out of the port, and whilst they run generators whilst they're alongside in the port. And of course, all the vehicles that use those vessels, so trucks visiting ferries, for example, are also emitting. So, and along with everybody else, the port needs to move away from decarbonisation and its reliance on traditional high carbon fuels. So the implications of this on ports, and we're particularly thinking about Portsmouth, is that one of the ways that shipping is becoming cleaner is through electrification. And one of the first targets of electrification is wider adoption of shore power. So it's interesting to note that particularly in Portsmouth, that the emissions and carbon emissions from ships underway are accounted for by the owners of those ships. But whilst the ship is alongside, they count against the carbon emissions of the port. So it's in the port's interest, not only from an air quality point of view, to provide shore power to enable the ships to turn off their diesel generators. But the power requirement for this is significant and exceeds the grid connection capacity in the port. Move a bit further ahead, some ships will move to fully electric propulsion with a variety of solutions, and their charging requirements in port will be an order of magnitude greater than the shore power required. So this slide shows the maritime energy transition that is now underway, but has a long way to go. So two targets, the decarbonisation and increase in air quality. So global shipping is estimated to contribute 2.7% of global greenhouse gas emissions. And there are targets for a 50% reduction by the International Maritime Organization, and the UK's overall target of net zero by 2050 is also important. And shipping is also a significant contributor to pollution and reduction of air quality. So the graphic you can see here demonstrates the predicted move of shipping away from entirely fossil fuels without carbon capture and storage in 2020 through to a range of alternatives in 2050, but completely eliminating that fossil fuel element. So to help achieve move us along that road, the PESO system is working in Portsmouth Port, which has 5 ferry berths, 2 traditional cargo berths. Interestingly, it's owned by the City Council, so it's owned by the voters of Portsmouth, and has very strong incentives to not contribute to air quality problems and reduce carbon emissions. And the grid reinforcement for the electrification of shipping in the port is very costly, in fact, prohibitively expensive. So electrical storage and energy management and the use of on-site renewables are a big key part of the solution for the port. So for example, from a carbon reduction point of view, in the port, they've already switched over all the LED lighting, switched over to LED lighting in the port, which has created a 60% carbon saving for that application. But for shore power, which is a much higher user of power, shifting to shore power is a 90% carbon saving and very significant air quality improvement. So the PEZO solution is using a smart grid technology to manage the flows of energy in and out of a hybrid battery storage system, integrating the on-site generation, which is primarily large-scale solar, and the on-site facilities, which is shore power, electric car charging, and power flows in and out of the grid. So this is the pilot scale battery, which is a hybrid lithium-ion lead battery, but the system is chemistry agnostic. So we're looking towards a organic flow battery is the next iteration, and that's me done. So not a huge amount of technical detail, but hopefully the aims of the project came across.
Excellent. Thank you very much, Simon. And a bit of a power up, but could I just keep asking people, do send in questions into the chat if you've got anything you're itching to ask our presenters. Next, I'm going to hand over to Laura Sandys. So Laura has chaired the Energy Digitalisation Task Force, which have been doing excellent work over the last 9 or 10 months or so, and have published their recommendations in the last couple of weeks. Laura's going to take you on what I'm sure is a whistle-stop tour of those recommendations. Laura.
Thank you, Damien, and thank you very much to UKRI, who've been very supportive over this project. I'm Laura Sands and was chair of this, but I have to pay the tribute really to the Energy Systems Catapult and that brilliant team that have really developed the presentations. We published a couple of weeks ago and really are hoping that Ofgem and BEIS and Innovate collectively will respond to our recommendations. We've worked very closely with them throughout, so this is an exciting time. So what is the problem that we're looking at? We are moving as an energy system from about 400 actors who absolutely know each other to millions of actions and assets. If you think every EV car can do 2-3 things, heat pumps, etc. This is becoming a super distributed system. And so the key challenges that we pose to ourselves is that we are going to have to manage multiple and changing customer preferences, definitely carbon visibility, which we don't really have within the system. New business models are going to emerge, and we're going to have to, in many ways, manage and understand the bidirectional contracting. We've heard about that already today. And so this is a very, very dynamic system. And it will not be able to be managed and made stable and resilient if we do it as we're doing it today. So we've been very much involved with the Catapult in looking at what does this new transformative change that data and digitalization can deliver. And we published the Energy Data Task Force about 2 years ago, and now we're looking at the Energy Digitalization Task Force's recommendations, which will be which are making recommendations about a lot more dynamic activity. So our purpose is getting the plumbing right, and we've currently got quite a lot of digitalization, some of which we've heard about today. But actually what we need to do is to have, and what our ambition is to, in many ways, implement a HTML of energy, allowing all these exciting things that are going on to what's called plug and play, rather than having to redesign the system each time with silos that actually will cause stability and resilience problems going forward. We use 2 use cases. One which I call prices to devices. And it's not that a wind farm and an EV car will communicate, but we need the architecture, the digital architecture, to enable demand and supply to communicate and to get visibility. We also looked at what we would call the energy system management stack. We're totally agnostic about whether this is decentralized, centralized, or all of the above, which, to be frank, I think that's where it will be. But our recommendations enable policy options to be expressed. So there is no sort of predetermined. So on to our recommendations. We had 6 key themes: unlocking consumers, unlocking interoperability, delivering a much more governance models that actually enable digitalization to happen safely. Very much looking at carbon and the decarbonisation agenda, and also looking at security, which is a key concern here. But one of the things that I won't talk about, but is really interesting, is around digital culture. So our very big highlights are, firstly, to unlock those consumer assets that we need for the system's resilience going forward. We are proposing a customer consent dashboard. We've got to build trust in this whole process. And that needs to be common, and it needs to be understandable by customers. And the second is that we need to mandate energy assets of a certain size in both the domestic, SME and industrial sector as being smart. We're still installing dumb heat pumps into people's homes, which will not actually unlock any of these, this potential. The second area is this issue about delivering interoperability. And we are proposing that Ofgem and BEIS commission to establish a very, very thin, super thin digital spine. This is the HTML of energy. And that is absolutely crucial if we're to unlock all the exciting things we've heard today. We are very conscious that actually implementing things is important, delivery, not just great recommendations. And so we are proposing that a delivery body, a digital delivery body is established, 3 years maximum, very, very tight, but there to deliver these core public interest assets, and then in many ways devolve those assets to other parts of the system. And the last very important one is about carbon monitoring. We really need to bear down on visibility of carbon, because we've got lots of different metrics and how we measure carbon. We're not measuring it actually just in time, and we need much greater granularity. And that is attracting quite a lot of attention from other parts of the sector. So we very much hope that these key highlights will start to unlock the digitalization, will ensure in many ways that some of the great innovations we've had today can get route to market much quicker. And it is absolutely limited to the thinnest layer of, in many ways, common public interest assets to allow commerciality to sit on top. But we think it's really important to get this done pretty quickly, because otherwise we're going to have lots of competing systems, lots of different digital approaches, which will in many ways create, as we call it, the Tower of Babel. Thank you very much indeed.
Excellent. Thank you very much, Laura. And last of all, we're going to go over to Chris Koenig, who is Programme Manager for the Ofgem Strategic Innovation Fund. Chris is going to bring us through some of the excellent work that we're doing on that programme. Chris.
Thank you, Damien, and good morning, everyone. My name's Chris Koenig, and as Damien said, I'm the Programme Manager at Innovate UK for the new Strategic Innovation Fund. This is a fund that is aiming to unlock greener ways to heat and power your homes and businesses and vehicles by harnessing the power of innovation whilst keeping bills as low as possible. Now, pipes and wires aren't something people often think about unless they work with them, yet they're incredibly important and vital, provide a vital service that we rely on for almost everything in daily life. The UK energy system is complex, with a lot of the design work dating back 100 or more years ago. The majority of our energy infrastructure has not been designed with zero carbon energy in mind. Recent government strategies are urging us to move away from natural gas to alternative methods, such as heat pumps or potentially in the future hydrogen. But to make sure that we can run a heat pump, charge our electric car, keep the lights on, we need to make sure that the underlying infrastructure is fit for purpose through whole systems thinking, digitalization and smart flexible management, as you have seen from the other presenters today. And this needs to be done at all levels, transforming our energy system from generation to transmission to distribution to our homes, businesses, schools and hospitals. With the Strategic Innovation Fund, we're building a green energy system, which is crucial to help cut out harmful greenhouse gas emissions. We need a culture change in energy that innovates with extreme urgency if we are to reach the government targets of net zero and tackle climate change. We need to take urgent steps to reduce emissions, to deliver value to consumers, to make a difference. Energy networks underpin our move to net zero carbon emissions, and this new £450 million Strategic Innovation Fund will help us find cheaper, faster and more reliable ways to do this, while saving consumers and all users of the energy network money in the long run. And it's funded by you, me, and anyone who pays a gas or electricity bill. And as we are the investors, it's vital that the projects funded deliver value, paving the way for net zero at the lowest cost. In addition, we recognise that the UK is an amazing place to be an innovator. The strategic investment approach is rarely, if not ever, seen in any other country across the world. This fund is a catalyst, aligning different pockets of energy innovation funding from public and private sector to make the UK the best place in the world for innovative businesses and academics to grow and scale their ideas and enterprises, leading to UK jobs and economic growth. We want the UK to become a magnet for energy investment, leading to national and international opportunities, all whilst delivering for our most important stakeholders, you. And work has already started. The first innovation competitions looking for ideas, the discovery phase, were launched last summer. For this initial round, we set 4 challenges for network innovation, which focused on whole systems integration, data and digitalisation, heat and zero emission transport. We were looking for big, ambitious ideas to transform the energy networks, projects that can make real differences and support the delivery of net zero. And we have not been let down. The energy sector reacted very enthusiastically to the launch of the fund, and in our first competition, all 9 of the eligible network companies submitted proposal, with a total of 55 received, 38 from gas network companies and 17 from electricity. And with the first funded projects to be announced soon, the Strategic Innovation Fund is starting out on an exciting journey hand in hand with the energy industry. Here's a taster of the projects. So the portfolio of projects that we have recommended to Ofgem for funding loosely fall into 5 categories, with some spanning 1 or more. In new technological approaches, we've received applications on novel nuclear technologies and multiple hydrogen applications covering hydrogen for heat, power, storage and transport. On other transport-focused projects, we've received proposals for decarbonisation of the rail systems, integration and flexible use of electric vehicles, and multi-fuel transport hubs. In addition to the flexibility services provided by mobile electric storage, a number of projects are also looking at the role of thermal storage and other methods of demand-side response and technology to improve grid stability. And a number of these will also look at the opportunities that digitalisation of the energy system will bring, taking a digital twin approach or using AI and machine learning to better inform and manage the complex systems involved in energy transmission and distribution, leading to a more resilient and sustainable network that reduces losses, maximises efficiencies, and can weather the impacts of climate change in the future. Key to all of these, and right at the centre of network innovation, is you, the consumer. Whether it's understanding adoption curves or behaviours, we're keen to see the results of the consumer-focused projects the most. But from little acorns, great oak trees grow. So we're taking a different approach to innovation, as the Strategic Innovation Fund requires all project outcomes to be embedded in our networks as business as usual. This means rapid de-risking of highly innovative ideas and onboarding of investors early on in the process to support growth and scale at the end of the project. We recognise that innovation is an adventure into the unknown, and things will not always pan out the way we expect them to. So capturing lessons learned and feeding them back into the process means that A, value is delivered for consumers' investment, B, others do not unnecessarily repeat the same research, and C, to help others inform approaches. After all, there is value in all outcomes, expected or not. Policy, regulation and innovation should work hand in glove, and strategic coordination and alignment across government, Ofgem, UKRI and the energy networks will ensure we are pooling all of our efforts effectively and tackling the issues. But high performance innovation is just not about energy networks. It's a whole system challenge. It's about pipes and wires, but it's also about you and your behaviour. If you're an innovator, do look at the Strategic Innovation Fund and come forward with your ideas. We're starting to develop our next round of innovation challenges now, with announcements being made early summer, followed by new competitions. We're delivering the funding to make it as inclusive as possible to all scales of innovators. If you're from an energy company or policymaker, foster innovation and help drive our networks to change for the better. And for all of us, we need to understand how we use or store energy and look for better low carbon ways of living. We either get there together or we won't get there at all. So to find out more and keep in touch about the Strategic Innovation Fund, please sign up to our newsletter. The next one is being published in about a week or so. I'll share the link in the chat, and thank you very much for listening.
Excellent. Thank you very much, Chris. So yeah, now it's time for your questions to the panel. And thank you for those who have sent questions through. So the first question we've had through, which I think was targeted at Will and electric vehicles, but I think it is possibly relevant to a number of the panel. But it's a question in relation to demand turn-up services and how you see those services developing, particularly in relation to high renewables penetration and high wind periods. So Will, I think if I can go to you first, your view in relation to EVs and what that can mean, I suppose, both for EV users, but also back into the system in relation to decarbonisation.
Yes, absolutely. So demand response services and particularly smart electric vehicle charging has a great opportunity to help balance intermittent renewable generation on the grid, such as wind and solar. And is well suited to align with this generation. So a lot of excess wind generation we have on the grid is overnight when vehicles are plugged in. And so we can align that overnight charging to soak up that excess generation and make best use of it. And as well with solar in the day, if people are working from home and plugged in, we can optimize to make best use of solar. In terms of demand turn-up services, the grid in terms of a constraint level is mainly focused on load reduction and demand turn down at the moment in the UK. But we are exploring already projects in California and Australia where solar is causing a problem on the network, and how we can do demand turn-up services with that, and also in Northern Ireland where there's a huge amount of wind, and that's also causing constraints. So I think in the UK it's really a timing thing. These services will definitely be needed, and we're developing solutions for them. It's just a case of priority and timing.
Excellent, and I think that you've got a good segue over to a question for Brian there. I think, because we've got the generation, and it sounds like we're going to have the development of assets and solutions to absorb that generation. But networks are clearly potentially one of the bottlenecks. So, Brian, can I ask you about what you're doing as SSEN to look at your role in sort of facilitating more renewable generation?
Yeah, absolutely, Damien. So one of the key developments for the LEO project is our peer-to-peer services, so the DSO-enabled services. And the one particular use case for that increase in generation is the offsetting service. So we have one market actor who, in a constrained area, who would increase their demand at the same time another market actor is increasing their generation by exactly the same amount. So we're trialling that service currently in a simulated environment in Oxfordshire, with the goal of deploying that service in trial period 2 this summer. So there's technical challenges in around that net effect of zero on the network, with the demand and the generation response at exactly the same time, which we're working through and we're developing. But yeah, certainly a challenge, and one that we're looking at within Oxfordshire.
Excellent, thanks, Brian. So the next question is directed at Lisa in relation to connecting the hybrid battery system down in Oxford to the grid. I definitely know there's learnings from a Habitat perspective, but can you share, I suppose, some of your learnings as an organisation and maybe as a project as well?
Yeah, for sure. So I guess there's first would comment on, it's not kind of a technological innovation that the battery is connected to the system at a transmission level, though it is noteworthy that we're using a tertiary winding connection, which enables us to basically, it made the process of connecting to the transmission network a little bit easier than it would have been if we were on the kind of primary winding. The innovation really came from working with National Grid and determining exactly what services we would need to provide as a unique type of asset, right? A battery is very different to any kind of other asset that exists on the transmission network, which is more, you're thinking kind of traditional synchronous assets, and seeing how we play a part in delivering some of the services that transmission connected assets are meant to provide. Things like LFSM and FSM, which are specific frequency response modes, is a kind of an interesting one to look at in the context of some of the other frequency response contracts that we're in as a battery elsewhere. So things like dynamic containment, but then even also things like reactive power. How much do we need to be providing versus other assets on the system. There's also an element of being a transmission connected battery means that you are more visible to the system. So in terms of providing services through the balancing mechanism, you become a much more significant asset, and you're as a result able to be leveraged by National Grid much more. So there was also conversations about kind of what does that actually mean. So overall, to answer the question about will it be easier in the future? Yes, absolutely, because I think part of this was just trying to kind of iron out some of the kinks in the grid code, essentially, so that it works for batteries as well. And so definitely, hopefully paves the way.
Excellent, thanks, Lisa. I'm going to jump in next with a question in relation to people, consumers, citizens, because I know I would definitely get it in the neck from Laura if I didn't mention that as part of this. But people can sometimes get lost in conversations like this, and I suppose I'm going to ask maybe Will, Laura, and Chris in relation to the role of citizens, and whether or not you think we're doing enough to prioritise and the needs of citizens in relation to the net zero journey that we're all on.
Could I sort of kick off here and say one of the things we've got to be absolutely clear about is how many acronyms have just been used in this last hour, all right? Could we start speaking English? I think this would be a really, really good start, because actually what we're getting is it's not just consumers, but we're getting new actors coming into the sector. Car companies, do they understand all this language that we're talking? Absolutely not. So we've got to look at ourselves and correct all of that. And then we've got to design the system around customers' experience. And customers' experience, customers' cost. We have had a system that has been absolutely supply driven. And in many ways, the customer has been a bit the victim at the end of the plug. Right? And we've got to reverse this. And a lot of sectors have reversed their system in what you might call old-fashioned business process re-engineering around consumers, right? And currently we're still, even in some of the great innovations that are going on, we're still trying to squeeze a customer into our proposition rather than building propositions around human beings who will have to play a huge part going forward. I mean, just picking up on Will's point about EV cars, from what I understand is by 2035, EV cars will have the same generation and capacity as 2 to 3 nuclear power stations. Yeah, so absolutely. Let's not forget that the customers are crucial. So change our language.
Thanks, Laura. And it's probably a good time to pass over to Will, because I know you guys are doing excellent work in your current PIFA project in relation to actually focusing on user experience and then, hopefully enabling grid services and flexibility and whatnot, which are not, top of the list for what users actually want from their EVs and their EV charging.
Yeah, absolutely, Damien. So our PIFA project, although there is a strong kind of technology and product development component in order to provide grid services at scale, one of the most important things for scaling is developing really compelling consumer propositions. So as Laura was saying, exactly what we're doing is developing those propositions around electric vehicle drivers and putting them in the driving seat, if you like. And why that is super critical is rather than always thinking things, sometimes we think about things from like an economics perspective and a whole system benefit and the value and the monetary value we can unlock. But what's really important to consider is convenience, and the convenience factor, and how people feel and respond to things as well. So that's why making electric vehicle charging and smart charging not only save money and carbon and all those rational things, but also just be simpler. So it's the default, it's the easier thing to do.
Thanks, Will. And Chris, if I can ask you a question in relation to what you're doing as part of the Strategic Innovation Fund and to enable, I suppose, cross-regulatory sort of barrier in innovation, but also to make sure that actually, you know, the end consumers, citizens, people are also involved in the innovations.
Absolutely. Yeah, thank you, Damien. So as I mentioned, you know, we're really excited because some of the projects that have come through that we're looking to fund are completely, you know, consumer focused. So we're really excited for that. And, you know, the metrics that we're using to determine whether or not the Strategic Innovation Fund has been a success, you know, 2 out of the 5 of them are, you know, delivering reduction in consumer bills and delivering other values to consumers. So we're totally focused on that. And as a result of that, we will be setting up a citizens assembly as part of the sort of program management to make sure that we're getting that kind of input. And we're also going to be kicking off some work with a number of consumer associations to deliver a consumer insights piece to understand exactly, you know, as you know, Laura and William were saying, how can we feed in those requirements and focus the entire lens on what the consumer needs, rather than looking kind of top down. Let's look a bit more bottom up as well. So
excellent. Thanks, Chris. So Simon, we've had a couple of questions in relation to your project down in Portsmouth. One is why was Portsmouth chosen as the sort of host for the project? And there's also some questions in relation to scalability of what you're doing down there, both across the UK and internationally, and whether or not it's the sort of nuances and the ownership structure of the port down there have any influence on that?
So choosing Portsmouth, a number of reasons, but people is actually a big reason. That Portsmouth, unusually, it's a municipal port, so it's owned by Portsmouth City Council, who work on behalf of the citizens of Portsmouth. So, in effect, the asset that's owned by the City Council is responsible for poisoning its own citizens. So there's a very strong motivator within the City Council and the port to clean up their act, to both particularly from an air quality point of view, but also in the longer term, to decarbonise. Also, from the people aspect, there is a particular enthusiast within the port who is keen on innovation and getting outside organisations in to help clean up the operations of the port. And they see this work as a crucial as a condition of them doing business in the future. So, for example, if a carbon price, if they carry on as business as usual, in a few years' time, what they would be having to spend on carbon credits, their entire profit. So that's no way to carry on. But apart from that, we've selected Portsmouth because it's, as much as you can, it's a typical port. It's got a range of activities, a range of different types of vessels visit. It's got a growing need for servicing the electric cars of visitors. And ferries, both cross-channel and in the shorter term to the Isle of Wight, are likely to be early adopters of all electric propulsion. So there's lots of reasons why Portsmouth is suitable. It's also quite convenient for us because we're based up the road in Southampton. It's also the right scale for a pilot project that's affordable within the scope of the project we're doing, but to demonstrate the scalability that you mentioned. So there are mega ports around the world, but they face the same problem. There are smaller ports that face the same problem. So we need a solution that is scalable. So hopefully that answers the question.
Excellent. Thank you, Simon. And can I thank all of our speakers today? I think we've been great on time and I'm sure everybody's got things to do at 11 o'clock. So I'll look to wrap up on time. So thank you to all of our speakers. if I can just have a minute, I'm looking to just briefly introduce a competition that we've just launched on Monday. I'll add links into the chat and you'll be able to get them on the catch up on when the video goes up on YouTube. But basically we've launched an SBRI competition on Monday this week, which is looking to fund open technology. So that's open source software, open hardware, or open data solutions. I'll let you look at the slides and I'll let you look at the link for more information. We do have a briefing event next week on the 9th, so do sign up to that if you're interested in more information. So that just leaves me to thank everybody for joining. We will have one more of these 6 and 60 webinars, and we shall update you over the coming weeks about those. And also this video will be uploaded to YouTube shortly, so we will let you know when that happens, and we hope you share that with all of your contacts. Thank you all for joining, and thanks to all the speakers.